Alright, this is the second side of the exponent review sheet. Again, like the other one, it's kind of small, but just pay close attention to your paper as you follow along, and that should help. On this page we have negative exponents, and we want to write them with only positives. So we know that if a number is right in front of our exponent, that's the base. So in this case, 7 is our base, nothing happens to that. And because it's a negative exponent, it's going to go into the denominator and becomes positive. And I think of it as like negative, you've done something wrong, you have to go into timeout, and then you're thinking about what you did wrong, and now it's positive. So letter number 3, 137 to the 0th power, anything to the 0 is 1, so that's the answer. Number 4, we have a base of 9, so that 9 tags along with the 3. It's a negative 3, so to make it positive, it has to go in the denominator and becomes positive 3. So 1 over 9 to the positive third. 5 is the same case. 12 is my base, so it tags along with the 6, and it's 1 over 12 to the positive 6. So that negative goes away when it's in the denominator. And number 6, my base is a, so I can take care of that first, and I'm going to get 1 over a to the 7th, because it's positive now. But that 3 is just a coefficient, so it's not connected, so 3 is going to stay in the numerator where it was, and that's my final answer, 3 over a to the 7th. Number 7, again, 14 is a coefficient. My base is g, so I can focus on that first. And I know that if I have a negative exponent, it goes into the denominator, so it's g to the positive 8th. And 14 is a coefficient unaffected by the exponent, so it's just going to stay in the numerator where it already is. Because really that's 14 over 1, so that 14 is in the numerator, which is why it stays in the numerator. Moving on down. Here we're going to be multiplying, so we know our rules of multiplying say if you have the same base, you add the exponents. So we're going to do that first. My base stays the same. You don't do anything to the base, but you add negative 5 plus negative 6 and get negative 11. But we know we don't want negative exponents, so it goes to the denominator, and it's 1 over 9 to the positive 11th. Number 15, our base is 11, so 11 stays the same, and I'm going to add 2 plus negative 4, and I get negative 2. But I don't want a negative, so I put it in denominator, and now it's positive, 1 over 11 squared. My base here is 5, so it's 5 stays constant, and I add 3 plus negative 9, which is negative 6. That negative has done something wrong, so it goes into timeout where it has to think about what it did wrong, or basically you just put it in the denominator, 1 over 5 to the positive 6. Now we have variables, t to the 8th, t is my base, so I add 8 plus negative 4, I get 4, and it's positive, so it stays the way it is. Number 18, v is my base, so v stays constant. Negative 10 plus 6 is negative 4, but I don't want negative exponents, so it goes into the denominator. Number 19, 3 and 8 are coefficients, so I'm just going to focus on the s's. 0 plus negative 5 is negative 5. Now I can go back and multiply my coefficients, 3 and 8, which is 24. So from here I don't want negative exponents, so my s to the negative 5th is in the denominator, but now it's a positive 5, and 24 stays up top. So my answer is 24 over s to the 5th. You also might have seen right off the bat that s to the 0 is actually just a 1, so this is just 3 times 8s to the negative 5th. Either way, it works out. Find the quotient. Okay, so write your answer using only positive exponents. So now we're going to subtract, and if it helps, write out what you're doing. 6 minus 12, because my base is 5, I get negative 6, so it's 1 over 5 to the 6th. My base here is 10, so I'm going to subtract negative 4 minus 5, which is negative 9, so I get 10 to the negative 9th, or 1 over 10 to the 9th. Number 24, my base is 17. I'm subtracting 5 minus negative 3. Minus a negative is really plus a positive, which is 8. So I get 17 to the 8th. It's a positive exponent. It stays where it is. Number 25, my coefficient is 15. My base is g. That's what I focus on. So I'm going to do 7 minus 5. Those are my exponents, and get 2. So I have g squared. And then I can take care of the coefficients. 15 divided by 1 is 15. And that's the answer. Number 26, my base is h. That's what I focus on. I'm going to subtract negative 8 minus 2. Negative 8 minus 2 is really plus a negative. I have negative 10. So I have h to the negative 10th. And now I can look at my coefficients. 21 divided by 7 is 3. So we saw before the h is going to go in the denominator. It becomes positive 10. But that 3 is just a coefficient. It's not affected, so it stays in the top. Over here, 20 and 16 are coefficients, so I'm going to subtract negative 2 minus negative 14. That's really plus a positive, so I get 12. So now I have f to the 12th, and I can go back and simplify 20 over 16. Simplify, basically we're looking at all these coefficients, what goes into both of them. 4 goes into 20 5 times, 4 goes into 16 4 times, so your answer is 5/4 f to the 12th. Alright, going to back to what we did at the beginning, 14 negative third, just writing these with positive exponents. It's going to be 1 over 14 to the positive third. This is going to be 1 over 9 to the positive 7th, 1 over 18 to the positive 5th. A stays the way it is. This is a to the first times b to the 0. A to the first stays a to the first. B to the 0 is actually just 1, so it's a to the first times 1, which we can just write as a. In number 6, the d is going to go in the denominator because it's negative and the exponent's 1, and the 24, our coefficient, just stays up top. So your final answer is 24 over d. Number 7, take them in separate pieces. M to the 4th is already positive exponent, so it stays in the numerator, but n to the negative 2nd, negative exponent, so it's going to go into the denominator, and it becomes positive. Alright, number 14. I can say I have the same base, so I add 0 plus 4, I get 22 to the 4th. Or I might have seen that 22 to the 0 is 1, so 1 times 22 to the 4th is just 22 to the 4th. Number 15, my base is the same, so I add 5 plus negative 6. I get negative 1, which is 1 over 8 to the 1st, or 1 over 8. Number 16, I'm going to have the same base of 12, so it's negative 4 plus negative 7, which is negative 11, so 1 over 12 to the 11th. Number 17, my base is w, so I add negative 9 plus 4 and get negative 5, and I multiply my coefficients, so my answer is 3 over w to the 5th. Here, my coefficients are 9 and 5, I do those later. Now I add negative 2 plus 10, and I get 8, and now I can multiply 9 times 5 and get 45. Number 19, my coefficients are 14 and 6, but I focus on my base, m and m. Negative 4 plus negative 9 is negative 13, and 14 times 6 is 84. So it's 84 over m to the 13th. Okay? Let's take a look at a few more. I'm going to subtract. Write out your exponents. Negative 20 minus 9 is negative 29. So it's a to the negative 29th. 18 over 8 can be divided by 2. I get 9 over 4. So my final answer would be 9 over 4a to the 29th because that negative goes in the denominator. Here I'm going to subtract negative 15 minus negative 16, which is plus the positive. My exponent's really just 1. And I can simplify. What goes into 30 and 34? They can both be divided by 2, 15 over 17. Number 25, negative 10 minus 16 is negative 26, so I really have k to the negative 26. 19 divided by 1 is 19, so my answer then is 19 in the numerator over k to the 26 in the denominator. 3 minus negative 8 is plus a positive, so that's 14r to the 11th. Here I'm going to subtract. 10 minus 9 is 1, so it's c to the 1st. 0 minus 5 is negative 5. So it's c over d to the 5th. And the last one, 3 minus 11 is 8, so w to the negative 8. And 13 minus 6 is 7, so it's y to the 7th over w to the 8th. That's all, guys. Good job.